Hi all, welcome back to my lecture series. This is Muthuminal, Assistant Professor at the Department of Agricultural Engineering. Today we will see the continuity on the topic which we have seen at the previous lecture series at is thermochemical conversion system that comes under the unit Advanced Machinery and Equipment in Agricultural Engineering 2 under the subject Automation Techniques in Agriculture Engineering for the students of second year 4th semester. We'll have a small recap which we have seen at the previous class, that is what are the processes involved in food processing like thermal processing, non-thermal processing, extrusion, freezing, and then we have also seen something about biochemical conversion system along with the combustion technology that is considered under thermochemical conversion system. We have also seen the conversion methods that are involved in thermochemical conversion and what are the three stages involved like conventional combustion, air staging and fuel staging, and how do we have to categorize them under the methods of utilizing like resources, technology and application. As of then, we could also have to see that what are the methods involved in thermochemical conversion system. The processes in which the heat is dominant mechanism and also to convert the biomass into another chemical form, the thermochemical conversion system plays a major role. The basic alternative are principally by the extent to which the chemical reaction involved are allowed to proceed, that is co-firing, direct combustion, gasification, pyrolysis and liquefaction. The main alternate method that is involved is co-firing and direct combustion. These two are the techniques which are utilized at several industries for identifying and obtaining the product heat from the industrial solution. And the gasification, liquefaction and pyrolysis are also plays a major role under converting the biomass into any other chemical form. The routes involved in thermal conversion are three, that is combustion, gasification, pyrolysis and hydrothermal. At the thermal conversion, when there is an excess availability of air, then the combustion has to be passed off, which results in the solution heat. And under gasification, it is not necessary for us to pass through an excess air, only partial air is necessary, which results in fuel gases which comprises of carbon dioxide and hydrogen. At the pyrolysis and hydrothermal, when there is no availability of air, then this kind of method could be taken care of, and this results in liquids as a out product, that means which will be given as any kinds of fuels. Okay, so while combusting I'll get heat, while gasifying I'll get the output as a gas, and while pyrolysing I'll get the output as a liquid. These are the routes involved in thermal conversion. Obviously there are three stages, one is combustion, one is gasification and the other one is pyrolysis and hydrothermal. So any stage, either I could get it as a heat, or I could get it as a fuel, or I could get it as a liquid. These are the routes. And as I have said at the previous slide itself, direct combustion plays a major role in uh, uh, converting the fuels into an alternate chemical form. That is why I have given you direct combustion specifically. Here the fuel and combustion plays a major role, where the air and fuel are infused into a combustion unit, and the resultant from the combustion unit will be the end product heat, combustion products and light. This fuel will give us a product of combustion along with an energy. So this is what happens when the combustion takes place directly. And the second one is biomass combustion. That is when I combust the wood, what happens in the sense the volatile matter goes off and the radiation will goes off to the surrounding environment, and the radiation, some of the radiation will go to the wood and the convective heat to the surrounding and results in hot flue gas, and also there will be an end product as burning char and ash. This is what happens while I combust the wood directly. This is called as biomass combustion. And these are the stages involved in combusting. That is, there are 4 stages, and I have separated each and every stage according to the temperature which has to be reached off. That is, initially it is under 100 feet. While I reach 500 feet, dehydration takes place. The water gets dehydrated and the particles gets converted into hemicellulose, and the initial stage of conversion into cellulose takes place at stage 1. And when the combustion heat reaches 700 Fahrenheit, the hemicellulose gets separated from the hemi and will be converted into cellulose, where the carbon dioxide will be vaporized. And at the third stage, when it reaches burning bush, that until 1000 Fahrenheit, nitrogen oxides will be given off, and also the organic molecules will also come off. Here 70% of heat generation will be attained at the third stage. This is what I have shown here clearly. At the fourth stage, that is when the heat has been reached to more than that of 1000 Fahrenheit, the remaining 30% of heat generation takes place, that results in an end product of char combustion, or it results in ash. Here the complex organic molecules, carbon dioxide and nitrogen oxides, along with the generation of lignin, happens at these kinds of third and fourth stage. This is the stage where higher level of temperature is attained, and the product which has been used for combustion will change its own property and convert into a powderish manner. Okay, so this is how the thermal conversion takes place, and this is what I have prepared for today's class. See you at the next class. If you guys have any kind of doubt, you guys can come and approach me. Thank you.